Okay, hello Year 12 further mathematicians. Just going to go through a second request from the internal exam, which was question 9 from paper 2. It's a differential equations question. Told you the context is modelling the insect population as time goes by. They tell you that, give you some initial conditions, they're called. Now these initial conditions, which I've abbreviated to when t is equal to 0, n is 400, and when t is equal to 1, n is 440, they're going to be probably used at some point to find the plus c. So I'm going to ignore them initially, because these initial conditions are only in there for us to find the particular solution, which is a fancy way of finding plus c at some point, because we always have to integrate at some point for differential equations. So that's what that is. Part A is write down a differential equation to model this situation. This situation is as follows. A scientist assumes the rate of increase. So the word rate means differentiate with respect to time. So that would be dn by dt is inversely proportional to the number of insects present at time t. Now the letter n represents the number of insects at a particular time. So inversely proportional would be 1 over n. And the only other thing I would mention for this is because the rate is an increase, that's a plus. Okay, if this population was decreasing, then I would put minus 1 over n. But the value of dn by dt is positive. The rate is going up. So as an equation, because an equation needs to contain an equal sign, this would be dn by dt is equal to k over n. Nothing to do with t in there at all yet. Alright, part B is to solve this equation. So this is called a separable differential equation. The letter n is on the top there. You take everything with an n in it to the left, and you take everything with a t to the right. So part B would be firstly times in both sides by n, like so, and then integrating both sides with respect to t. The reason you do that is because they cancel, and integrating n with respect to n would go to n squared over 2. Integrating k with respect to t goes to kt, and we have, don't forget about it, the plus c, which needs to go on one of the sides. Now this is called the general solution, because every single differential equation has infinite amount of solutions, and the plus c gives you the general solution. But we want to find the particular solution, and that is the very specific plus c that works for these initial conditions, the ones I mentioned right at the start. So those stated that when t was equal to 0, n was equal to 400, and if I substituted that in, I'd get a half 400 squared is equal to k zeros plus c. And if I simplify that, 400 squared times a half is 80,000. That's the plus c. But why did they give you another initial condition? They also give you t is equal to 1 and n is equal to 440. And that is to work out the other missing letter, which is the letter k. So you need to do that as well. So a half 440 squared is equal to k times 1 plus c, which we now know is 80,000. And if you make k the subject by doing 440 squared, times in by a half, and subtracting 80,000, you get k is 16,800. In other words, that equation, the general solution there, becomes a half n squared is equal to 16,800 t plus 80,000, and that's called a particular solution. Now they, just check to see if I've answered the question correctly, they want to find n in terms of t, which is another way of saying make n the subject. So if I want to make n the subject, I times by 2 and square root. So n would be equal to times everything by 2, and then square root. If you considered plus or minus for square rooting, it's obviously a plus, because the context of the question, number of insects, you can't have a negative number of insects, so that's why I've picked the positive root. There's a part C, which is worth 6 marks. Start a piece of paper for part C. So part C makes a slight revision to this model, because the initial model would have been way too basic. This next one takes into account a few other factors. Who knows what those factors are, but it's just not purely just inversely proportional to the number of insects. There's other things going on as well. So part C is dn by dt is equal to n squared over 3,988 e to the power of 0.2, I think, t. And this is just a more complicated separable differential equation, but the initial steps are the same. The n's go to the left and the t's stay on the right. So divide by n squared. Leave the t's on the right. Now, one thing I'm going to do, which is remind you that that right-hand side would be 1 over 3,988 e to the power of 0.2t, or I prefer that, which is 1 over 3,988 times 1 over 0.2t. Some of you did the right next step, which was integrate with respect to t, because they cancel. But your instinct for this should always be index form. A lot of you just saw fractions and thought, well, it's got to be logarithms, but the instinct should always be, can I write stuff in index form and use basic integration that you were taught first? And the only time you end up using logarithms is if you've got 1 over n or 1 over x or something like that, really. So your instinct should be, firstly, okay, does index form work? So let's see if it does. N to the power of minus 2 dn, and this is another negative power, e to the minus 0.2t dt. And if you integrate the left hand side, you can add 1 to the power and divide by the new power. E is a little bit different. E kind of integrates and differentiates to itself. But whatever this multiple is, in this case the multiple is minus 0.2. You have to divide by that. So you divide by minus 0.2. Remember the plus c. Let's tidy this up. Left hand side would be minus 1 over n effectively, or minus n to the minus 1. The right hand side is, I have no idea what that divides to, so I'm going to type it into my calculator. So 1 over 3988 divided by minus 0.2 would be whatever that is. Minus 5 over 3988. Remember, e to the minus 0.2t plus c. And I guess we've got to use those initial conditions again to work out the plus c. So let's substitute in t is equal to 0. We get n is equal to 400. Substitute that in, those initial conditions right at the start. Minus 1 over 400 is equal to anything to the power of 0 is 1. So that effectively goes to 1. So you just go this plus c. If you make c the subject, so that's my answer. So we've got minus 1 over 400. Add that answer, we'll subtract that answer. Doesn't look right. Minus 497 over 398 800. And then that would be, in other words, sub that in, minus 1 over n is equal to minus 5 over 3,988 e to the power of minus 0.2t minus 497 over 398,800. Doesn't look like very nice numbers, and I need to make n the subject. So the obvious first step to make n the subject is times everything by minus 1. Get rid of all the minuses. And then attempt to flip the fractions now. So in order to flip the fractions, you need a single fraction on the right hand side, effectively. So in order to get a single fraction on the right hand side, they need the same denominator. So the only difference with the denominators is an extra couple of zeros there. So I can put an extra couple of zeros there, an extra couple of zeros there, and then flip everything. So you'd get n is equal to everything flipped 398,800 over 500 e to the minus 0.2t plus 497. Hopefully that's correct. We will see. Let me just quickly check the mark scheme. Otherwise I could have been talking complete nonsense. Question 9. I can't see the answer. Finally, question 9. Zoom in. Yeah, yeah, they've just divided by 100 for some bizarre reason, but that is correct. That will be it.